Hello everyone. I welcome you all for today's video's lecture, Linear Regression using Gradient Descent, and myself, Ms. G. Mareeswari, working as an assistant professor in the Department of Information Technology, Ramco Institute of Technology, Rajapalam. Before moving toward today's topic, I just want to explain you about what is meant by linear regression. Actually, linear regression is one of the supervised machine learning algorithm. It is mainly used to learn the pattern from the labeled data set. Linear regression is always try to find the relationship between the input and the output variables in the data set. Here, in linear regression, it assumes the relationship between the input and output is linear. The goal of linear regression is to find the best fit line as a straight line. This straight line will always tries to minimize the error. The best fit line is represented with the help of the linear equation formula y is equal to mx plus c. Here x is the input, y is our predicted output, and m is the coefficient, that is a slope, and c is the intercept. With this information, we will move towards how to build linear regression model using gradient descent algorithm. Actually, gradient descent algorithm is mainly used to find the best fit line for a given training data set in a smaller number of iteration. It is used to minimize the square function. It is mainly used to minimize the error value. Actually, here the error value considered as mean square error. So in order to minimize the error value, we are calculating the gradient of the cost function. This gradient is calculated with the help of a partial derivation. Actually, a regression model uses this gradient descent mainly to update the coefficient values. After that, it will more significantly try to reduce the error value of the cost function. In order to do this, we randomly select the values for coefficients in the initial stage, and after every iteration, we need to update the values until we reach the minimum coefficient values for the cost function. Gradient descent is this gradient descent is called as an iterative optimization algorithm. Why it is called so? Because optimization is mainly concentrated on reaching the maximum or minimum of something, right? Here, here also we are trying to find the minimum value for the cost function, and hence it is called iterative in the sense it repeatedly update the values in each and every iteration for the coefficients. So this gradient descent is also called an iterative optimization algorithm. It is mainly what's based on the concept of loss function. So we repeatedly use this term loss function, right? We should know what is meant by loss function, and we should know the formula. First, loss is nothing but error. Error is defined as the difference between the original output and the predicted output. Here, the error formula for consideration is mean square error. So the formula for mean square error is E is equal to 1 by n, summation I is equal to 0 to n, yi minus yi bar the whole square, where n is nothing but the number of data or number of observations in the data set. Yi is the original output and yi bar is the predicted output. The formula for yi bar is mx plus c. Here in this equation, I just replace this yi bar with the line equation formula mx plus c. This is the equation for the error function or loss function. In order to understand this concept, just consider this case study. I will explain at the last how it is related to our concept. In this case study, there is a person who is needed to reach the bottom of the valley. So here the goal is to reach the bottom of the valley. The person with no sense of direction, he doesn't have any sense about direction. Here this person goal is to reach the bottom of the valley. So here, when the slope is high, he will take the large step, and when the slope is small, he will take the small step. This is the concept. The person will take the next position only based on his current position. So these are about the informations about this particular case study. I will explain you how it is related to our concept in the last slide. First, how our gradient descent methodology work to build the linear regression model. Here I will going to explain you step by step. The step one is in step one we need to assign values for every variables. Here the coefficient m is initially considered as 0 and the intercept c is initially assigned as 0 and the L be the learning rate. Its value is considered as 0.001. Actually, L is responsible for controlling the changes of m in each step. Selecting small value for L is good in order to get accurate output. Step 2 is finding the value for dm and dc. Dm and dc are nothing but the in order to get the value for dm, we need to partially derive the error function with respect to the coefficient m. So to find this formula dm, we are going to partially derive the error function e with respect to the coefficient m. So here consider this particular term, it become mx square. It is now mx square, right? If we partially derive this particular term with respect to m, it will become minus 2xi. Mx square will become here because there is a minus in front of it. Minus mx square will become minus 2mxi, right? So once we partially derive this error function with respect to m, the formula will become 1 by n summation I is equal to 0 to n 2 into, because minus xi is taken at the end and 2 is splitted and taken in front, 2 into yi minus mxi plus c into minus xi. Here this particular term is the our linear equation, predicted equation, right? So we can replace it as yi cap again in the next step. So now the equation is again simplifies to dm is equal to minus 2 by n summation I is equal to 0 to n yi minus yi cap into xi. Similar to that, we need to find the value for dc. We can find the value of dc by partially derive the error function with respect to c. Again take that error function slide. So here if I partially derive this particular equation with respect to wait, okay. If I again partially derive this error function with respect to c, here consider the equation, it is consist of c square. If c square is partially derived with respect to c, it will become 2c, just 2 only added in front as a coefficient, right? The equation will become 2 by n summation I is equal to 0 to n yi minus mxi plus c. That's it. Only one term is added in additional, that is nothing but 2. So now the value of DC become a so now the value of DC become minus 2 by n because the minus is common for both mx plus c, right? So minus is also applicable for c. Now the value of DC become minus 2 by n summation I is equal to 0 to n yi minus, instead of writing mx plus c, we just written directly it as yi cap, right? These are about the values of dm and dc. In step 1, we assign the values for the constant coefficients, and step 2, we have find the value for dm and dc. In step 3, we need to update the values of m and c. In order to update the value of m and c, we have considered this formula. M is equal to m minus l into dm and c is equal to c minus l into dc, where m is the value of current value of coefficient. Here in step 1, it is considered as 0 and L is the learning rate and dm is the value of error function after it is partially derived with respect to m. Step 4 is we need to repeat step 2 and step 3 continuously until we reach the goal. That is until we reach minimum error function or 0% error. the last step, uh, the value of M and C at the last iteration should be the optimum value for both M and C. Now, I just want to explain how this particular gradient descent is related with our analogy. Here, M is considered as the current position of the person, and D is considered as the steepness of the slope, whether it is a large slope or it is small slope. Deepness of the slope is represented with the symbol D, and L is represented as the step he taken, whether he is taken large step or small step. Now, the value of M, next M is depends on the current value as well as the sleep and the step he was taken, the person was taken, how slope the valley is, and whether that particular person is taken larger step or smaller step. Like this only decide whether this only decide whether what is the next position of that particular person. The person will continuously update his position from one location to another location until he reach the minimum value here in our analogy, until he reach the bottom of the value. This is corresponding to our loss function will become 0, right? For this particular process, we are mainly concentrated on finding the values of M and C. So the major work which was played in building the linear regression model is finding the values of M and C. In order to find the values of M and C better way, we are moving towards this gradient descent method. Gradient descent, again I am insisting, gradient descent is nothing but it is a concept of finding the values of M and C by partially derivating the error function. I just want Next, I want to explain you one simple program for this concept, linear regression, how to build this linear regression model using gradient descent. For this, I am just going to explain you with the help of Colab. First, we need to import all the necessary library files such as NumPy, Pandas, Matplotlib. NumPy is useful for numerical activities and Pandas to deal with the dataset. MATLAB, Matplotlib is for a visualization purpose, right? So here I have load the dataset here. So in this dataset, only two columns are available. One is the input column and another one is the output column. Once I have read the data, I need to assign which is the input and which is the output. The first column is considered as input and it is assigned to the variable X. And second column is considered as output and it is assigned to the variable Y. And here I have just shown the scatter plot of this data set. It shows how the data are distributed here. Next is the core part, that is how to build the linear regression model with the help of gradient descent concept. The first step, assigning values for the variables. Here we are assigning M value as 0, C value 0, and value of L as 0.001 in order to get the better accuracy. Here the number of epochs we need to continue is mentioned as 1000. So here we are going to predict the values of Y. Here we know the original output value Y. In order to predict to find the predicted value, the formula is Y prediction is equal to MX plus C, right? After that, we need to find the value of DM and DC in order to get the better value of M and C in each and every iteration. For every epoch, we need to update the value of M. To find the values of M and C, we should find the value of DM and DC. In the slide itself, we clearly explained how to calculate the value of DM. That is nothing but by partially differentiating the error function with respect to M, we can find the value of DM. By partially differentiating the error function with respect to C, we can find the value of DC. So here I have just mentioned the mathematical formula for DM and mathematical formula for DC. Once we get this answer for DM and DC, we can update this value of M and C by using this formula. The formula for finding the value of M is equal to M minus L into DM and C is equal to C minus L into DC. This will continue until we reaching the final epoch, and at last the last value of M and C will be printed as the output. Here the final value is provided as 1.47 for M and 0.10 for C. This is the best value for M and C to find the line of best fit. Here, in addition to this, I have drawn the line of best fit for a better visualization. So this is the final output of our concept. Here the linear regression goal is to find the line of best fit. This line of best fit is always helpful in predicting the output when we are provided with the new input. So this is also provided in this slide. This is the reference where the content is taken. I hope the video is clear and I hope you all understanding the concept well. Thank you.